Hi, this is Mrs. Mochizuki.
And this is Miss Kaiser. And
Today we're going to be learning about inscribed angles and polygons, section 10.4 in your textbook.
yes, so get out your note packet and open it up to 10.4, inscribed angles and polygons. Everybody ready? Here we go.
Today we're going to talk about our inscribed angle. So let's first figure out what it is. An inscribed angle is an angle that has a vertex on a circle. And the sides of the angle are chords of the circle. You can take a look at the picture below. See point B? That's the vertex of the angle. And now you can see that both sides AB and BC are chords that are the sides of the angles, and check out that arc. You see the arc that we've drawn in red is what we call the intercepted arc. So your inscribed angle intercepts arc AC.
There you go. So next we're going to learn a little bit about how to relate their measures. So we learned in the past that an arc measure is equal to the central angle, but this angle is not a central angle. So,
Since this angle is not a central angle, it's going to have a different measure. Look at it. If you think about the central angle, it's going to be a lot bigger than the angle. That's the inscribed angle at D. So D turns out to be exactly half of the measure of the intercepted arc.
so if arc AB is 100 degrees, that means measure of angle ADB equals 50 degrees.
Very nice.
Everybody ready to do some examples?
Why don't
Okay.
you go ahead and give it a shot? Try to find the measure of each and we'll go over them afterwards.
Yeah, take a moment, and we're going to do B first and then go to A. So see if you can find arc DG. Okay, I think you might have it. Arc DG, the angle, the inscribed angle is angle E, which is 40 degrees. So arc DG is 80 degrees. Now Ms. Mochizuki is going to explain A for you.
You can see that on this problem, we were given the arc instead. Arc EF was 58 degrees, and you're asked to find angle G. And we've highlighted the arc and the angle for you, so give that a try. What do you think will be the measure of angle G? You probably have it by now. Let's check this out. Did you get 29 degrees? That is correct. Notice that if you have the angle, you multiply it by 2 to get the arc. But if you have the arc, you divide it by 2 to get the angle.
All right. So we're going to move on with more interesting information about circles and arcs and angles. So an inscribed angle of a circle theorem. So this theorem says if two inscribed angles of a circle intercept the same arc, then the angles are congruent. So you look at angle ADB. So if arc AB is 100, then angle ADB is 50. Now Ms. Mochizuki is going to explain the next one.
But if you look at angle C, it intercepts exactly the same arc, arc AB. So it will also turn out to be 50 degrees. So you didn't even need to think about calculating that one. If you can see that they both intercept the same arc, you know they have to turn out to be the same.
All right, so you should be able to just look at that and know that they are both 50 degrees. All right, here are some examples.
Okay, why don't you go ahead and find the measure of angle B in each diagram?
So, looking at problem A, hopefully you figured that out by now. Notice that we know angle D is 81 degrees. And we know angle D intercepts arc AC. We also know that angle B intersects the same arc AC. So we know that angle B and angle D are congruent. So that means that angle B, which is X in this case, must be 81 degrees.
Now try B. Okay, let's check out B. You can see that angle C intercepts arc AD, and angle B also intercepts arc AD. So what will the measure of angle be? B? It's going to be 68. Notice we don't even need to figure out the measure of the arc in order to get this. As long as they're both intercepting the same arc, you just know they're going to be the same measure.
But if you wanted to know what arc AD is, you could figure it out. Miss Boach, can you figure out what that arc is?
Yes, I can. Let's see. It's 2 times 68, which would be 136, right?
Yep.
Okay.
Awesome. But we don't need to know that for this problem. But maybe another problem we would. So C combines what we learned in, I don't think it was the last section. I think it was 10.2. Mm-hmm. We learned about that if you have a central angle, and in this case, angle T is a central angle, it will equal arc SQ.
Right. But we also have angle R there, which is an inscribed angle, so we know that it's only half of SQ. So why don't you go ahead and see if you can figure out what the measure of angle STQ is, which is labeled with an X. So find X.
And notice in this problem, we're not solving for B because there's no B there. So this is... So what I did was I found arc SQ first. And arc SQ is 102 because it's 2 times 51, which is 102. And then I asked my friend, Miss Mochizuki, now what's X?
Well, in order to find X, we just have to remember it's a different type of angle than angle R. It is a central angle, and central angles are equal to the arc. So this one is super easy. We know it's equal to the arc, so X has to be equal to 102.
Right. And technically that's angle STQ, which is X. So there's a little typo there. Moving on.
Now we are at what happens when you have an entire polygon that's been inscribed into a circle. Okay, remember that when something is inscribed into a circle, it means that all of its vertices are on the circle. And the circle is said to circumscribe the polygon. And we've seen this before, but now we're going to see what happens to the measure of the angles when we have a polygon inscribed into a circle.
Okay. So does everybody understand what an inscribed polygon is? That means the circle is circumscribed about it. That means each vertex of the polygon is on the circle.
Okay, so there is going to be a new theorem here, and it's actually one that's going to come in handy quite often, because if you look here, we have a diameter. You can see that segment AC goes through the center of the circle, which is D, okay? And if you then draw an angle B that intercepts that diameter, also you can say it intercepts the semicircle. Okay, we now have a triangle, and you can see that the hypotenuse is the diameter, and since angle B is intercepting arc AC, and it's an inscribed angle, it has to be a right angle, half of the 180.
So the bottom line here is if you have an angle inscribed into a semicircle, it is 90 degrees.
Every single time.
Every single time, without fail. Here we go. So I bet you guys can figure out what X is here. First of all, is angle X, WXY, inscribed in a semicircle? So like Miss Moach said, every time that angle is going to be 90 degrees.
Mm-hmm.
And that angle is 5x. So figure it out.
There you go. Every time it's 90.
So x is 18.
Now try B. B's a little different because you're given information in a different location, okay? But you can still figure out something. That theorem we just learned actually goes both ways. If you see a right angle that's inscribed into a circle, what do you know about that hypotenuse that's opposite it? Well, it has to be a diameter. Therefore, angle F, must have been inscribed into a semicircle. That helps you figure out X. Now you find X.
So we've listed that DF is 120, and then FE is X, and then ED is 180. I bet you guys got it already.
So what is X? X turns out to be
360 minus 180 minus 120, which is 60 degrees.
Another way to do that problem would be to realize that, since going from D through F to E, a semicircle, is a semicircle also, you could have just said 180 minus 120 in order to get the 60 degrees. It's really cool in this chapter how sometimes you can find an answer in many different ways.
Yep. All right.
Here we are at our inscribed quadrilateral theorem. We have a quadrilateral there. Remember, that's 4 sides. Okay? If you check it out, we've already marked angle E. The angle that's opposite E would be angle G. This says something very interesting. You can see that angle E intercepts arc FGD. And angle G intercepts arc FED. Together, they have intercepted the entire circle, right? So they are both half of the circle, half of the arc rather, because they are inscribed angles. But since together they intercept 360 degrees, together they will add up to be exactly half of that, 180 degrees. That's 1/2 of the circle. So that means that anytime you have a quadrilateral inscribed into a circle, any pair of opposite angles will always be supplementary, because remember, angles are supplementary when they add up to 180.
Thanks, Moach. That was a great way to explain that. Find the value of each variable. Remember, ABCD is a quadrilateral. It's got 4 sides. So you can get 2 equations. So what would be the equation that helps you get A? Go ahead and write that down. Then go ahead and write the equation that helps you get B, and write that down. Now I want you to check to see if you got these equations. That's the equation that helps you find B, and that's the equation that helps you find A. Now, I know you guys are a whiz at this, so go ahead and solve those algebraic equations. Moach is going to tell you what the answers are.
Okay, let's check this out. It turns out that A is equal to 23 and B is equal to 115.
Right. And A was just a one-step problem, and B was 2 steps.
Right. Simple algebra. You guys can do that.
The other way around. A was 2 steps, B was 1 step.
Oh, that's okay. So here we are with another quadrilateral inscribed into a circle. So quadrilateral UVWY is inscribed. And they've given us one measure, 68, and they've given us one variable, x, and we have to find x. So see if you can apply this theorem to this problem. Write your equation and then solve it. Notice that 68 and x are opposite angles, so what has to be true? They have to be supplementary. They add up to be 180. So x plus 68 equals 180. And then you just solve it. Very simple solution.
Subtract 68 from both sides, and you've got your answer as 112 degrees.
Very nice.
Great. Okay, we're going to move on. I believe there's another theorem next. Oh, no, there's a construction. So we know you don't have tools. We understand that. So we're just going to talk through how to do this. So constructing a square inscribed in a circle. So the first thing you want to do, you've got your circle with center C. So you want to draw a diameter and label the points where the diameter intercepts the circle as AB.
There you go. The second thing you want to do is you want to construct a perpendicular bisector of AB. We do this all the time. We've been doing this all year long. So remember, put your compass on A, open it up more than half of AB, make an arc, and then put it on B and make the arc. I just said it backwards. Oh well, I think they get the idea. Sorry, but we are kind of wimpy with the compass here because we don't have tools when we're creating this online. So here we go. You make your perpendicular bisector and then you draw the perpendicular bisector. Mark the endpoints as D and E, and then you're ready to roll. Ms. Kaiser?
Then you're just going to take a straight edge, and you're going to connect A to D, D to B, B to E, and E to A. And there's your square.
Isn't that cool? It turned out to be a square. A little bit off because our construction wasn't perfect, but
Right.
if you did a good construction, it would look just like a square.
Right. All right, moving on. Wow, looks like we have some more examples here of everything we learned. So we're going to use all the theorems that we learned in this section and see if we can answer each one of these questions.
Okay?
Miss Swantish?
Shantis?
Yeah, Miss Swantish just stepped in, and she's going to finish these notes with us, so she's going to grab a chair.
Come on over, me.
Come on
Swantis.
over. We've been having fun teaching this lesson, so now we're going to keep on going. We're towards the end of the lesson.
I'll start with A.
Okay.
Okay, notice on A, you have to find 3 different things. You're looking for one arc, that's A, and you're looking for 2 angles, B and C. So we're going to give you a little time in order to get those.
So hopefully you were able to get A. Hopefully you just used the theorem from section 10.2 and you knew that that was a semicircle, so you just did 180 minus 122 and you got A. But I guess I got B first.
Well, that's because B is easy. It's inscribed into a semicircle, so that one's quick. It's just 90 every
Right.
time. Every time it's a right angle.
Well, and then I got C because
C, if you can look at it, it is an inscribed angle, and the arc it intercepts is the one that's marked with 122 degrees. So take half of 122, and that's 61 degrees.
and then we're left with A, which was just 180 minus 122.
Very nice. Okay, now we're going to try problem B. Again, you're given a couple of arcs, but you're asked to find 3 different angles. So let's do this. Give you a little time here. Okay, let's check it out. Look at angle A. Okay, angle A is intercepting an arc. Which arc is that? Well, it looks like it's the one that's marked with 56 degrees. So angle A is an inscribed angle intercepting an arc of 56 degrees. So angle A will be equal to half of 56 degrees, which is 28 degrees.
And then angle B, the arc that intercepts is 94. So angle B will be half of 94 degrees.
Okay, now let's look at angle C. Oh my goodness, that is not inscribed. It's not a central angle. We can't see what arc it intercepts. What are we going to do? Well, if you check out that picture, you have a triangle. The triangle has two angles you already know, 28 degrees and 47 degrees. That leaves the third angle in that triangle easy to figure out, because all you need to do is 180 minus 47 minus 28. And that angle is a vertical angle with angle C. So why don't you go ahead and do that? So it's going to turn out to be 105. It's 180 minus 28 minus 47. That gives you 105 for that angle below C. That is his vertical angle buddy, and they are congruent. 105.
Awesome. Thanks, Moch. Here we go. Next problem. See if you guys can get this. Next problem. Take a moment. I recommend maybe getting A first. How do you get A, Moch?
Well, what I see there is we have a quadrilateral that's inscribed into a circle. And angle A is opposite the angle that's marked 87 degrees. And when you have a quadrilateral inscribed in a circle, the angles opposite each other have to be supplementary. So that means to find A, you just have to subtract 87 from 180.
Cool. There we go.
And that gives you 93.
Awesome.
So now that we know A, we can move on to the next part. Miss Kaiser?
Let's see. We got to find arc B and arc C. So how are we going to do that? Let's see. Well, arc B, what I see there, took me a moment to figure it out, but I noticed that that angle 78 intercepts arc B plus 36.
Yes, it does.
So we know that B plus 36 is twice of 78. Right?
Exactly.
So hopefully I wrote the equation down here.
Oh, we did C next. Oh, well.
Oh, I did C next. So what did I do
But
for C?
C's the same thing, because angle A is the inscribed angle that intercepts the arc that covers both C plus 36. So C is going to be double that angle, and double that angle is, remember, A is 93, so if you double 93, you would get 186, but then we don't want the 36 included in C, so we need to subtract that from 186, and C turns out to be just 150. This will show B now.
And B is, we just went straight to 120, so it looks like we didn't show the work there.
Yeah.
But twice of 78, you double 78, and then you subtract 36.
Right, 156 minus 36 will give you the 120. Okay?
All right, moving on. All right. Find the value of each variable here. So, if you look at problem D, what kind of triangle is that? Moch, what kind of triangle is that?
Well, I see that all three sides are marked congruent, so it must be equilateral.
Wow. So, what are the angles of an equilateral triangle?
Well, if I recall, an equilateral triangle is also equiangular. So they have to add up to 180 and be the same, so there's 60 each.
Great, they're 60 degrees. So, then we know B is?
60 degrees.
So then A is twice B because A is the intercepted arc of angle B.
Which is an inscribed angle. So double it.
Right. So we've got B, which is 60, and then A, which is twice 60, which is 120.
Right. That wasn't so bad.
Not at all.
Okay,
We just had to remember that the angles were 60 degrees.
Look at E. Okay, notice you can clearly see that there is a dot in the center of that circle, so you know that you're looking at a diameter when you see that dot in the middle.
So angle A is inscribed in a
Semicircle.
semicircle. So angle A is
Always the same thing, 90 degrees.
always.
Every time
Now,
you've got
oops,
an angle
I
inscribed
went really
in a
fast here.
semicircle.
Sorry about that. I'm going
Oh,
to go
that's
back.
quite all right.
Okay, so I guess I got B first.
Okay.
And so I got B first by I got D.
D.
I
okay.
called it D there.
Oh, she just doubled the 40 because it's an inscribed angle, and that made D 80.
Yeah, so we just labeled D there, even though it wasn't there.
And then C is just going to have to add up with 80 to make that semicircle, which is 180. So you're going to subtract 80 from 180 to get 100.
Right. And then I believe we got A, which we already knew was 90. And then B we knew was 37. Or no, B is not 37. The unmarked angle in that triangle is 37 because it's half of 74. So angle B was 53. You also could have just taken 180 minus 74 and then divided by 2.
Right. You could use the inscribed. We use the fact that the three angles had to add up to 180, so to get angle B. And so, you just had to subtract 180 minus 37 plus A, which was 90, and that gave us the B of 53. But using the inscribed angle is maybe even easier here.
Right, yeah. And also, it's
good
a
to-
right triangle, so you really just needed to subtract 37 from 90.
Right.
Quicker
Yeah,
way.
there's so many ways you can find these things. That's what's really cool about this chapter.
And sometimes you want to do it in the order like A, B, C, but this time we did it in a different order. It just depends on, you don't have to do it in a specific order. You just got to find all the
Another
variables.
thing I like to do is once I've gotten one of these, I like to go and write it on the figure so that they're there as clues for the next one.
Right, which we did with the 37.
Right.
All right, on to the next one. What do you think? Which one would you find first?
Wow. You know what I see there? I see lots of inscribed angles because we've got 3 different ones, and we're asked to find 2 of them, and we're asked to find an arc. The arc is pretty easy to find now because the inscribed angle that is 39 degrees intercepts the arc that's marked A. So we know that angle of 39 degrees is half the arc. So A would just be 2 times 39. Let's see if we did that one first on the...
Yeah. Yep.
Yep.
2 times 39.
Okay.
78. And then I knew that B was 90 because inscribed in a semicircle, always right angle, always 90 degrees.
Okay, that one's a simple one. Looking at C, angle C intercepts an arc that we don't have a mark on. Okay, so what I would do here is since I have a semicircle on the top half of that circle, I can see that on the left side there, I have a 50-degree arc. And together, those 2 arcs that make up that semicircle will be 180. So that leaves 130 degrees for the arc that C intercepts. So, C's an inscribed angle, it will be half of the 130 degrees, which is 65.
Awesome.
Okay.
So this is notes for 9-4, which is what we were going to teach on Monday. So hopefully you...
10-4.
10-4, thank
Good
you.
buddy.
Yeah, 10-4. Got it. 10-4, good buddy. So hopefully you watch this on Monday. And we are also going to post links to the worksheets for you. And we will send out an email explaining this
Yes.
to you. And hopefully you've read the email before you listen to this video.
Right.
And then the online homework, that'll all be explained in the email. Have a great day.